Hi, Mr. Andrew here, and today we're doing remainder and factor theorems. So this means my function f of x, graphed right here, if it crosses at the x-coordinate a, that means a is now an x-intercept, is what we've traditionally called it. It also means that it's a, not a factor yet, but it's a zero or a root of the function. What's going to lead to is where it's going to be involved in a factor. And that's exactly where we're going to go next, is the factor theorem. So if f of a equals 0, if it is a 0, then there is a factor of the polynomial theorem, or there's a factor of the polynomial, according to the factor theorem, that is x minus a. Okay? So that means you have to flip the sign when you're taking it out or putting it in. And this is something we've dealt with after we factored even quadratics and they were set equal to 0. We'd take each one set equal to 0. And if you solved it, every time it would flip the sign. So moving between a factor and the actual 0 or the actual root, you need to flip the sign, okay? Meaning that it's going to appear with a different sign inside the linear factor rather than just by itself on the graph. So here, let's move forward with this. If x minus a is a factor of the polynomial, then that means if I divide a into, if I divide a into the polynomial using either synthetic, or if I take the factor and divide it into the entire polynomial and use long division, either way, I'm going to get a remainder. The remainder is going to be the same as f of a. The implication here is that we have a way of finding if something's a 0 of a function just by taking the number and plugging it in. Okay? Very interesting. So what we can do now is we can combine this all together. If I have, and that's about it. Thanks for watching. If you have any questions, just email me.